Hi everyone, welcome back. This time I'll be covering the pattern generator function of the MSO-19. What sets the MSO-19 logic analyzer subsection apart from other budget price logic analyzer is the pattern generator, which you can access from here. It's capable of going from 100 microseconds per point to 10 nanoseconds per point. It has a buffer size of 1024. It's capable of outputting on all 8 channels, or you can select which channels that you want to turn off. It can go from continuous, where you can do a loop count down to custom loop, how many times you want to loop it. It can start and stop from different parts of the buffer, and it's got some predefined patterns that you can use to generate output. You can do this on the fly from sample to sample basis. For example, I want to sample from here to here. I want to go output, I want to go high, and then I want to shut it off again to listen to the response coming back from your circuit. This is a pretty powerful function for embedded controller guys or the FPGA designers. So let's do a quick demo. Bring up a clean slate, and let's see. Right now there's should be nothing in the pattern generator mode. I'm running this at 1 kilosamples per second, and I'm going to trigger bit 1. And what I have hooked up right now is just a simple LED to channel 0 of the logic analyzer. So what we're going to do is we're going to select a zone. Let's see, we're going to go from channel 0, 96, 194, we're going to generate a high. And so the waveform, actually the easiest thing is that let's do all 7 channels, makes it easier to see. And we're going to select all the output, and this section will be set for high. We're going to run the logic analyzer at 100 kilosamples or 10 kilosamples per second, or per point, or 100 microseconds per point. We're going to loop it continuously. We're going to run the pattern generator manual. We're going to do a manual start. This pattern generator is capable of starting when the scope triggers, synchronize when you hit the go button on the scope, or you can manual start. For now, we're just going to do a manual start. Hit done. Wait, hold on. Go back to. I forgot to turn it on. Manual start. So you see the green button pops up. So now, if we hit go, you see the LED blinking, and that, if we run the logic analyzer on it, you see it blinking. And time between pulse on this is and we're blinking roughly 102 milliseconds, and pulse width is running about pulses around 10 milliseconds, which is roughly what we have in this pattern generator setup, because we told it to set up about 100 samples worth, so 94, 96. So what can you do with just one LED? Well, you can kind of blink it really fast. Or what I have hooked up is, a PWM signal for demonstration. It's just a I just have 7 LEDs, or yeah, 7 LEDs hooked up. I had a breakout, and all the wires wired to the connector. This is just the harness coming in from coming out of the logic, the MSO-19. So I'm gonna load up a little file. So this file, go on the pattern generator. It's basically one long pulse second, and then progressively gets smaller and smaller and smaller. So your duty cycle for the signal is going to go lower. It's going to be go lower and lower duty cycle, and it's going to run at 20 microseconds. Hit go. You notice the brightness differences. And we set up the logic analyzer. We can actually see. We can see the signal locked. The pulse width for each one of the LEDs gets less and less and less. The first one is just forever on, so that's the brightest it will be, and then gets narrower and narrower as and the duty cycle will change, going from full on at full on, and then it goes for the period between the two is about 20 milliseconds down to about 800 microseconds. So what can you do with something like this? Well, sometimes it's kind of fun to be playing with the persistent vision thing. As you can see, this is blinking, but this is the basic principle of persistent vision. As we start moving it, you see the duration, how long each one of the pulses compared to the other. So what else can we do with this? Well, I can also use this pattern generator to trigger a very, very big light. How big? Let me show you. This big. This is a recycle LED lamp. You know, they claim 25 years. They don't hit 25. I got about 3 years on this before the MOSFET went dead on this. So I took a power supply, a 48 volt power supply, or negative 48 that I salvaged from a telecom salvage yard. Put a photo MOS driver to give me the isolation, and then a high voltage MOSFET drive it through, and I pump. So we're pumping about 48 volts into 39 LEDs. So how bright does this puppy get? Then we're gonna stop the PG, and I'm gonna wipe this whole entire thing out. Then we're just gonna generate a short burst on channel 0. And we'll loop it. Connect the PG up. And notice the blink. We can slow this guy down a bit more. For your full epileptic seizure enjoyment. But this also allows us to experiment with different. It's a good demonstration to demonstrate PWM and how do you dim lights. Well, that's it for today. And if anybody interested in how to build this monster, I'll have a separate video about it. Thank you.